Children, in the previous video, I have done constructions. So now, in the same similar triangles, in the same chapter, we are going to do some more important problems. We have done all the constructions I have taught to you. Page 212, certain constructions I have done. Now, page 212 only, from page 212, you have got certain example problems which are also important. So now I am going to do with example 5. This is very important example, children. The problem is a person 1.65 meters tall casts a shadow 1.8 shadow 1.8 meters, and a lamp post casts a lamp post casts a shadow of 5.4 meters. So you have to find out what is the height of the lamp post. This is the question, children. What is the height of the lamp post is the question. Figure is given to you in the textbook. So let me draw that figure here. We have got this is A and B, and this is one right triangle mentioned here, and you have another one PQ. P and Q, and this is the shadow given to you. So here AB is 1.65 meters, and PQ we don't know. This is height of the lamp post, and AC and PR, these are what? These are the sun's rays. And BC, this is C, 1.8 meters, and QR is 5.4 meters. So children, when two things, suppose like this, two things are, this is here, if sun's rays are falling from the other side, what happens? The rays will fall in the same direction, because it's only one sun that is giving out the rays. And one more, the property of the rays, what you can understand, the rays are always parallel. Sun rays travel in straight line, light rays travel in straight line. You have learned about that property in your previous class. Experiments also you have done in science. So always the sun's rays travel in straight lines, and also they all are parallel to each other. So here the person is standing. So these are the rays of the sun, and here the lamp post. Lamp post means what, children? The street light lamps are there, pillars are there, like that. A pillar for which the lamp is hanged. In the olden days, they used to hang the lamps. So that is this here. So this is the shadow that is occurring for this lamp post. Now, this is the shadow of the lamp post. These are the rays that are coming from the sun, and they are passing like this. This is the shadow obtained. See, if you have here, its shadow is obtaining here. So when sunlight is at the back, the shadow comes in the front. So BC is the shadow of this AB and QR is the shadow of PQ. So you need to find out what is PQ. So let us write what each one indicates. What is AB, children? AB is the height of the person. Okay. BC is shadow of the person. And what is PQ? PQ is the height of the lamp post. And QR is shadow of the lamp post. Now, these two are right angled triangles. Now, let us see that. In triangle ABC and triangle PQR, in these two triangles, angle B is equal to angle Q because they are perpendicular. Always man stands perpendicular to the ground, as well as a lamp pole stands perpendicular to a ground. It is understood. So definitely they are 90 degrees. Now when you see this angle C and angle R, children, angle C and angle R, as I said, these two rays are parallel. You just forget about this. This becomes the transversal. If this is the transversal, if I close like this, two parallel lines and a transversal, these two becomes corresponding angles. Okay, so we will say that angle C is equal to angle R. They are corresponding angles. Therefore, what you can say, triangle ABC is similar to triangle PQR basing on angle corollary. Triangle ABC is similar to triangle PQR basing on angle corollary. And if two triangles are similar, what you can say? Their sides are proportional. You have learnt about the theorem where when you say that two triangles are similar, they are corresponding. When can you say that two triangles are similar? Only when their corresponding sides are proportional and corresponding angles are equal. So here we have got two angles are equal. Angle corollary is actually it is a corollary, means it doesn't need any proof, like axioms they are. So whenever in two triangles, two corresponding angles are equal, then definitely the two triangles are similar to each other. So when two triangles are similar, it means their corresponding sides are proportional as well as corresponding angles are equal. Here in this problem we are concentrating upon corresponding sides. So what you can say, therefore, we can say AB by PQ. AB is the height, PQ is the height, is equal to BC by QR. Remember, children, if you are taking numerator of this triangle, here also numerator for the same triangle you have to take. So this is 1.65 by PQH is equal to BC 1.8 by QR 5.4. So what you can say here, how will you prove 1.8 into height h. 1.8 h is equal to 1.65 into 5.4. So what is h? 1.65 into 5.4 by 1.8. 1 pointed, so this decimal and this decimal you can cancel. 18 threes are 54, so this is 3. So multiply 3 5s are 15, 3 6 are 18, 1 19, 3 1s are 3 1 4. So 4.91. Therefore, H is equal to 4.95. So height of the lamp post is equal to 4.95 meters. This is the answer of this problem, children. I hope you have understood. Please copy this. This is example 5. Now, we will go for example 6. What is example 6? The next example 6 here. A man sees. A man sees. So it is a lengthy problem, children. I will read for you. First, let me draw the diagram so that I can explain that along with the statement here. So the diagram is like this. You are having ED and this is AB somewhere here. This is 1 and I need to join this. This side, this. So this is A and B. This is C. And this is D. This is E. And here it is given as 1.5 meters. And this is 0.4 meters. And here 87.6 meters. And this is H. That means this is how much we have to see. So see the problem, children. What is it? A man sees the top of a tower in a mirror which is at a distance of 87.6 meters. That means this is the tower, children. ED is the tower. So there is a mirror here. This C is nothing but mirror. So what is happening? The person is standing here. AB is the person. What is he doing? He is getting in the mirror the shadow of the tower. So the mirror is open like this so that he can see through this mirror the shadow of this. A man sees the top of the mirror at a distance of 87.6 meters. The mirror is where? The mirror distance between the this ED is 87.6 meters. So a man is seeing the tower. This is the tower, children. Tower, from the base of the tower at 87.6 meters, a mirror is there. It is opening like this. And then man is AB. He is seeing from here in the mirror the image of E. Okay. And the mirror is on the ground facing upwards. Then only he can see the image. The man is 0.4 meters away from the mirror. From the mirror, the man is 0.4 meters away from the mirror. And his height, the man height is 1.5 meters. And then how tall is the tower? This is the question, children. So what is AB? AB is the height of the man. And what is ED? ED is the height of the tower. And what is BC? Distance between the man and the tower. And what is CD? This is also distance between the tower and the mirror. Okay, children. Now, what you need to find out? What is ED? You have to find out. AB value is given as 1.5 meters. This is how much you have to find out. Distance between the man and the tower is given as 0.4 meters. And distance between the tower and the mirror is given as 87.6 meters. So these are the measurements that are given to you. Now we have got two triangles. One is triangle ABC and another one is triangle CDE. So let us take those two triangles. In triangle ABC and triangle CDE. In these two triangles, angle B is equal to angle D. They are 90 degrees. Listen children here. See, this is mirror, no? Mirror means this ray is called incident ray. Okay? This is incident ray. And this is called reflected ray. So that is incident ray. This is a reflected ray. So law of mirror, that is law of reflection, you have studied children in physics. So if you draw a normal like this is called normal ray, NR I am writing. So what is this children? The angle between incident ray and reflected ray is angle of incidence. And the angle between reflected ray and normal ray, angle of reflection. And always you know that angle of incidence is equal to angle of reflection. This is one of the laws of reflection. So, when you say that angle of incidence is equal to angle of reflection, now let us see. Angle C plus angle I is equal to 90 degrees. This is a normal ray, no? So, angle I plus angle C is 90 degrees. Also angle, here C means you may be having ECD, I will write children. Here, angle ECD plus angle I, and here angle ACB plus angle R is also equal to 90 degrees, because here this is also 90 degrees. That means what children? Angle ECD plus angle I is equal to angle ACB plus angle R. But angle I and angle R I am cancelling. Why am I cancelling? Because angle I is equal to angle R. So I am cancelling. Therefore what I am saying? Angle ECD is equal to angle ACB. So see children, angle B is equal to angle D, 90 degrees. Angle ECD is equal to angle ACB. We have proved. Therefore what you can say? Triangle ABC is similar to triangle CDE basing on angle corollary. If these two are similar, corresponding sides are proportional. Therefore, AB by ED is equal to BC by CD. What is AB children? AB is 1.5 by ED, we don't know, that is H. And BC is 0.4 by CD is 87.6. Means 0.4 H is equal to 87.6 into 1.5. This means, what is H? 87.6 into 1.5 by 0.4. So this will get cancelled. This is 1.5 children. Now with 4 you can cancel this. 4 2s are 8, 4 1s are 4, 4 9s are 36. With 4 you can cancel. So 21.9 into into 1.5 15, not 1.5 point, already we have cancelled. 15 9 jar 15 9 jar, how much children? 135. Okay, so 5 I will write it here. I am getting 30. Okay, 15 1 jar 15. If you add, how much you are getting? 28. So 8 here, 2 is there. 15 2s are 30 plus 2, 32. So that means 328.5 meters. This is the answer. Therefore, height of the tower is equal to how much? 328.5 meters. This is the answer. So this is example 6, children. Copy it. I hope you have understood this problem. Copy this. This is example 6. Next, we will go to the next one. Now, example 7. What is example 7? So, example 7 also is a big problem, children. Writing that is difficult. So, first I will draw the figure. Gopal is worrying. So, figure is given to you for the examination. So, first let me draw the figure. The figure is like this. You have got a base here, and here this is one side, and here you have got AB, and these two I need to join. After this I need another one like this. So here you have got a broken line like this. You have got a broken line, and you have got another figure here like this. This one extension. This should go like this. So here you have got another one like this. Now the names mentioned here as A. This is P, 1.5 meters, and then this is Q, this is 2 meters, and this is also 1.5 meters, this is also 1.5 meters, here 1.2 meters, and this is D, and here you have got B, and here you have got E, this is C, and this is R. It is a perpendicular one, 1.5. Okay, this is given to you, and this whole distance R to P, this is 8 meters. R to P distance is 8 meters. So let me read the problem, children. By observing the figure, you can understand. Gopal is worrying that his neighbor can peep into his living room from the top floor of his house. So this is Gopal's house. This is his living room. This is the neighbor's house. This is the top portion. So what is that he is worrying? From the top of on the top floor of this one, sorry for disturbance, children. From the top floor of this, he is having a doubt that he can observe this their living room. So they lose the privacy, if somebody is looking into their living room. So what he wanted to do, he wanted to obstruct that view. How can he obstruct the view? Only one thing that he can do. What he can do? He can raise his compound wall. See, he had decided to raise the height of the fence that is high enough to block the view from the neighbor's top floor. So he wanted, this is actually the fencing, children. He wanted to raise the fencing so that from here he cannot view this, because this will obstruct him. Okay, what should be the height of the fence? Total height of the fence will be how much? The measurements are given in the figure. So this is the figure, children. This is the height of the fencing, and this is also height of the fencing, and this is also height of the fencing. This is the top floor of the building, and he may get a view like this. So he wanted to build a fencing, raise the fencing. So here what you are getting, children, here you are getting two triangles. One is triangle ACE and another one is triangle ABD. So let us directly go to the problem, children, here, because writing the steps is very means lengthy. So we can go for the problem, because the diagram also is given directly. We can go. Now we will go to triangles. In triangle AEC and triangle ADB. I hope you are seeing, children. AEC is one triangle. ADB is another triangle. In these two triangles, definitely these two are perpendicular. Angle C and angle B. So angle C is equal to angle B. They are 90 degrees. And angle A is equal to angle A. They are common. Both are common. Angle A is equal to angle A. Therefore, what you can say, triangle AEC is similar to triangle ADB basing on angle corollary. So on this way you can say two triangles are similar. When two triangles are similar, their corresponding sides are similar. So for this triangle EC by DB is equal to CA by BA. CA is the base, BA is the other base. So what is EC? They have already given 1.2. By DB, what is DB? We don't know. That is height HR. Let us write it as DB only. We will write it as DB. DB is equal to CA. What is CA from here to here? Whatever is this distance, this is also same. That is 8 by BA. What is BA, children? They have given here 2. This is 2 means this is also 2. So what you can say, children? 8 dB. 8 dB is equal to 1.2 into 2. What is dB? 1.2 into 2 by 8. 2 ones are 2, 4s are 4 ones are 4.3. So dB is equal to 0.3. So what is the height of the fencing? Height of the fencing means what, children? You need to add both original height as well as this. So what is the original height, children? That is height of fencing. Height of fencing is equal to originally 1.5 plus 0.3. That is 1.8 meters should be the height of the fencing, so that he cannot view the living room of the other building, Gopal's building. So I hope you have understood, children. Write down this, copy this problem. This is example 7. Now let me go to the next part. That is 8.2 exercise, children. Exercise 8.2. In this few problems are important to you. So in 8.2, what are the important? Some second problem is important. What is the second problem, children? The perimeter. The perimeters of two similar triangles. It goes on like this. So let me read the problem for you. The perimeters of two similar triangles are 30 centimeters and 20 centimeters respectively. What is the meaning of perimeter, children? Perimeter means the sum of the three sides. They have given the sum of the three sides. As first triangle 30 centimeters and second triangle 20 centimeters. If one of the side of the triangle, first triangle is 12 centimeters. Out of two triangles, one triangle side is given. Determine the corresponding height of the second triangle. So you are having triangle 1 and triangle 2. So what is given to you? Perimeter of triangle 1 is how much? 30 centimeters. And perimeter of triangle 2 is 20 centimeters. Then what else they have given? One of the sides, one side of triangle 1 is equal to 12 centimeters. So what is the corresponding side of triangle 2 is equal to how much? This is the question. We know that when two triangles are similar, then their sides are the corresponding sides are in proportion. When you say if corresponding sides are proportion, then definitely the corresponding perimeters also will be in proportion. So what you can write? Perimeter of triangle 1 by perimeter of triangle 2 is equal to side of triangle 1 by side of triangle 2. So this is 30 by 20 is equal to, the first side is 12 by, let us take it as x. That means 30x is equal to 20 into 12. What is x? 20 into 12 by 30. Zeros will get cancelled. 3 1s are 3 4s are 4 2s are 8. So what you can say? The corresponding side of triangle 2 is equal to 8 meters. This is the answer. This kind of sums, few sums I have selected, children, which I feel that they are very important. Please go through before going to your SA-1 examination. So write down this, children. Copy it. Next. Next one is 7th problem. For 7th problem, they have given a figure. So let me draw the figure here. This is AB. Okay. From here, it is joined here, and you have another one, and these two are joined. Okay, now A, B, C, D, you have got here also a perpendicular. This is considered as PQ. This is 90 degrees, this is 90 degrees. This is X, this is Y, and this is Z. Now what is that you have to prove? You have to prove that 1 by X plus 1 by Y is equal to 1 by Z. This you need to prove, children. Now, in this figure, you have got two triangles, children. One is triangle, actually this is ABD and it's BCD, you are able to see. But triangle ABD itself is divided into two triangles because of PQ. So, let us take that. Let us start the proof. In triangle ABD and triangle PQD. I hope you have seen, children. ABD, PQD. In these two triangles, definitely angle B is equal to angle Q, 90 degrees, and both of them are having the same angle D. Angle D is equal to angle D, common. Therefore, what you can say? Triangle ABD is similar to triangle PQD basing on angle corollary. So these two triangles are similar. Therefore, what you can say? Therefore, when two triangles are similar, corresponding sides are proportional. That is, AB by PQ is equal to BD by QD. I told you, children, when you are taking this side, then divided by this corresponding sides. Then for this triangle side only we have to take BD by QD. AB is how much? X. By PQ is Z is equal to BD by QD. Okay, children. Now let us write the reverse. Why are we need to write? I'll tell you. Z by X is equal to QD by BD. This you consider it as first equation. Why are we inverting? I'll tell you as I am proceeding with the problem. Now we have got triangles. In triangle BCD, I can say BCD, and triangle, what is the other one you have? BPQ. BPQ. In these two triangles, see, BCD, BPQ, these two triangles, what I can say? Angle D is equal to angle Q, 90 degrees. And then, what else I can say? Angle B is equal to angle B. Angle B is equal to angle B, common. Therefore, triangle BCD is similar to triangle BPQ basing on angle corollary. So we have got these two triangles are similar. So because these two triangles are similar, so let us see what I can do here. These two triangles are similar means CD by PQ. CD by PQ is equal to BD by BQ. What is CD, children? Y. By what is PQ? Z is equal to BD by BQ. This also, Z by Y is equal to BQ by BD. This is second equation. Now, we take first equation and add it with second equation. Z by X plus z by y is equal to qd by bd plus bq by bd. Why did I do so? Because to make this as equal. Here this means LCM BD QD plus BQ. What is QD plus BQ? QD plus BQ is nothing but BD. So BD by BD. You can cancel this. This is nothing but 1. So what am I getting here, children? You may not see this. I am writing here, children, above. No place for me. So please cooperate. So here I am writing z by x plus z by y is equal to 1. I take z as common. 1 by x plus 1 by y is equal to 1. What is this means? 1 by x plus 1 by y is equal to 1 by z. Hence, rule. A very, very important sum, children. I have seen this sum in SSA examination also many times. Please understand it carefully. It's in fact a very simple sum because it is dealing with the similar triangles and the property of similar triangles. Only the thing, how you need to take the triangles, which side you have to do. That if you are perfect, you will get a perfect answer for it. So please go through it, children. 2-3 times you rewind and see, so that if you have any doubt, I think that the doubt will be clarified. See, after this, I have written here, children. Please see that properly. This is the solution part. Lengthy problems cannot be fixed in this board. So I am trying to search for the space and write. So I hope you have followed this. Now after 7th problem, already I have done constructions. That's all, children. Up to 7 only you are having. So 2 and 7 problems are important. Up to this, in 8.2, these are the sums that are important. I hope you have done it. Let me first once again check whether any other thing is important. That's all, children. These are the problems. So go through them when you are going for examination. You have to copy it. Next part I will be doing in the next class.